Alright, welcome to part 8. This section will be about creating a table in the database we created in part 7. We will go over the basics of editing a database table to set it up for data collection. We will work with MySQL Query Browser to manipulate the database so that later we can add sensors and work with Python scripts, among other things. It will be relatively easy to import the data to the database, and from there we can create charts, web pages, and analyze collected data. Alright, so if you haven't already, download MySQL Query Browser. If you haven't already, you probably haven't watched the previous section, part 7. You probably should go watch that. Otherwise, if you're familiar with how to log into MySQL Query Browser, we'll just go ahead and get started. So first, you'll want to bring up SSH connection to your Raspberry Pi. This will be through Secure Shell or through Terminal from the desktop. Once you're in, you'll want to do sudo su, which gives you root permissions, and then we're going to go ahead and jump into MySQL with the command MySQL u root p, like so, and we're going to enter our password that we created in previous videos. And now we're into MySQL, and so first off we're going to take a look at tables, because today's episode is basically about creating a table and how to edit that table using MySQL Query Browser. But we should understand where that comes from. So now that we've logged into MySQL through Command Line, we'll use Command Line in MySQL to show tables. I'm sorry. First you'll have to select the database. We use the use command, and the database in this case is Greenhouse. You'll select the database that you created in the previous video. You'll see that it says database changed. And then we'll go ahead and do show tables, semicolon. It must be in all caps, otherwise the command will not be accepted by SQL. So in the description of the video I'll put the actual commands that you can copy paste if you need to. Anyway, we're going to show tables. You'll see that there is an empty set there right now. So we're going to create a table using Command Line just to show you how it works from Command Line, so you'll understand what it is exactly we're editing in the database when we use MySQL Query Browser. Just want you to have an understanding what the basis behind all that is. Anyway, back to it. I'll put the statement for this in here, and this is just a base default statement. There's more information on creating tables. There's a link here. I'll put the link in the description as well. Anyway, we're going to create a table called pet. Okay, and so we're just going to copy and paste this in. We're going to hit enter. You'll notice that it says query OK, 0 rows affected, so that means it created the table. And then we'll go back now and do show tables, and you'll see that we have a table called pet in there. Now that's not the table that I want to create or call it, so I'm going to go back and delete that, and that way you'll understand how to delete a table as well. You want to be very careful with database commands though, because if you were to delete a database that you didn't intend to delete and you hadn't backed it up, you would lose it. So drop table, in this case it'll be pet. Send the command, and we'll go back and we'll look with show tables again. And you can see we now have an empty table set again. I just wanted to help you understand that from a command line standpoint, so you understand what it is we're manipulating and how powerful a tool MySQL Query Browser is. With that, we'll exit using the exit command or quit, and we'll just leave ourselves in root there, and we'll go on over to MySQL Query Browser and we'll learn a little bit more about that. So you go to your start menu, MySQL Query Browser. I should point out there are other toolkits in here as well. We're not after those, we're after the Query Browser for the moment. I suppose what I will do is log into the Greenhouse Pi quick and show you a running operating example so you have a better understanding of what we're trying to achieve and accomplish. So we'll go ahead and log into the Greenhouse, and I'll we'll open, let's see, first of all, you'll notice that there are two different tables in here. The farm table, well, two different tables that aren't a part of the original installation. These here are all part of MySQL and PHP-MyAdmin and all of those pieces. You should not modify or mess with any of those. So let me go into, so this is a table, and you'll notice if we click on it, left click on it once, I'm sorry, this is a database. Solar is a database. Farm is also a database. And you'll notice if we click on each of these and drill down, we'll end up with two different tables in two different databases. So the database farm is not currently in use on this. I just haven't gone back and deleted it. The current database in here is this database Solar with the table temps. So if you go down here and you right click on it, you can edit the table. Now sometimes if you have trouble getting that to show up on the menu, it's because you haven't selected this database as a default schema. So let's just address that quick. You would right click on the database that you want. You would go all the way down to the bottom and left click make default schema. And now that way you're working on the database Solar. And then you can go to the table temps. If you double click on the table temps, it'll throw up a default command line, or MySQL Query command line, or a query statement is actually what it's called, so that you can pull all the data from the database. I won't do that to you right here, right now, because it'll take about 1.5 minutes to return all the data that's in this database. So what we'll do is create a statement that limits the amount of data we pull, and we'll be a little more selective about it. This will kind of help you understand how the SQL query language is very powerful and flexible. So we'll do select star from temps, order by date underscore time, and then we'll say descending, so we list it descending, and we'll say limit, and we'll say 1,440, which is the number of minutes in a day. So we'll go back and look at the last day's worth of data collection, since we're logging data once every minute all day long. All right, so we'll go ahead and execute that statement. And you'll see the data comes back. It tells you how many rows were fetched, 1,440, and how fast it came back. And the first thing you'll notice is that there is a tremendous amount of data here. And also on the bottom here, you can scroll back and forth across the entire set of rows in the table. So let's just take a look. The ID here, you'll notice this is a counter basically. So we have a way to identify each data log set or each row kind of in the table, so that we can find it later, or sort it, or manipulate it later, or compare different ones and be able to see which one came first where. Along with that, we have greenhouse ID. You'll notice that that's just one constantly. That's part of how we work with the coding language. We'll get into that more later on. You'll notice we have date time. This is the date and time that each data collection event from the Python code is taken, and it logs that along with the other data that's grabbed. That date and time is taken from the Raspberry Pi itself. In this case, in the greenhouse, I actually have a GPS hooked up to it, and the time synchronization is run off of the GPS for a very accurate time base. We will probably look at that later on. Especially for, this works especially well for cases where you want really precise time. And the other thing that you can get out of this is if you don't have a connection to the internet and you have no way to check other time servers, you can keep time synchronization on the Pi independently of internet connection or other server connections. So that's a very valuable tool in that way. But that's a whole separate topic. Just want you to understand a little more about it. Next, we have modified. Modified is in case you use an SQL query statement and you change a data value. it'll log when it was modified, and then you'll have another way to sort against the database and be able to find things that were created on one date and modified on another. It's just a very powerful kind of a base information to be able to help search out particular things. You'll see why that's important later on. So next we'll just look at these are all different sensors. So we have like east high, east low, west high, west low, stove, Tmass or thermal mass, outside temperature, BTUs in storage, average greenhouse temperature, delta T is a difference in greenhouse temperature versus outside temperature, delta mass, and so on and so on and so on. In any case, each one of these values is either collected directly from a sensor or collected from a sensor and then calculated and number crunched in the Python code before being submitted to the database. But so far, I've got about 2 years of data collected on here, so I can go back and look at different trends and look at how much energy I've used in the greenhouse and just a whole host of stuff, and I plan to keep adding more sensors and really dialing this in more. Eventually I'll be adding a rocket stove that directly heats a thermal mass system, and probably controlling that entirely with the Raspberry Pi as well. Although I might use an Arduino with the Raspberry Pi as a data collection unit backing it, which would be a little more robust hardware way to do things. Anyway, I'm getting sidetracked here. I'm trying to teach you about MySQL Query Browser. So anyway, you'll notice there's sensors all across and all sorts of information, and it's pretty much limitless how much data you can put in here. It's quite a lot. Anyway, so now that we've done that, we'll go back and we'll close this, and we'll go back and we'll open MySQL Query Browser again, and we'll log in to the Trainer Pi, and we'll create a table, and we'll help you better understand how to do this. So I've created the database greenhouse, and you'll notice there are no tables in it right now. So just like we did with Command Line, but this time with the mouse, right click, we'll make a default schema first, and we'll right click again, and we'll say create new table. Okay? So now we have to come up with a name for the table. Let's just call it data log, since we're logging data. You can put a comment in here. And then we'll go down here and we'll start working with things. Let's go back and take a look here at some of the basics. Our first one, we should do an ID. It'll be an integer. It'll be not null. It'll auto increment. It'll be unsigned, zero fill, and a default value of null. So let's start with that. Okay, so we'll create the table like so. ID of the type integer, not null, auto increment, unsigned, zero fill. We'll go down and we'll create the next one, which will be greenhouse ID. Oh, greenhouse underscore ID, and it'll be an integer. And yep. So uncheck that. Okay. Drop that. And we'll come back over here. The next one is going to be date time, date underscore time. And yeah. Let me go back to the editor. it'll be date underscore time. Got to double click first. Date underscore time, and it's going to be a data type date time, not null. No need to auto increment, I think, and then unsigned zero fill. Actually, let's go back and check. It's been a while since I've done this. So, and then we need a default value over here, which is going to be the format 4 zeros -00 -00 and then a time. So it's going to go like this: a default value of 0000 -00 -00 space 00 colon 00 colon 00. We're going to want to surround that in a single quote and then hit enter. So what I'll do, Control A, C, is put that in the description just so you're not confused. Okay. So that's that. That's the default time or date time. Now we're going to go back and do okay, well this will be your first, modified. We'll do modified timestamp not fill current time. So modified timestamp not null let me just double check this. Yeah, not null checked, everything else blank, and then current time. So not null blank 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 and then current underscore time, I believe. What we'll do is open another instance of MySQL Query Browser and double check that. I just don't want to give you wrong information here. So we'll go back to the greenhouse pie, which we know is solid. And we'll go to solar, temps, order by, wait, we don't need that. We just need the table editor. Too used to writing statements. Edit table. And it'll be Control A, C, escape. And then we'll go back to the other table, and it is current underscore timestamp. Current underscore timestamp. Okay, and I will put that in the description as well to simplify things for you. Because those are critical. If those aren't right, you won't be achieving the goal you want to achieve. Now, although we don't have a sensor yet, we'll go ahead and add a value in here for sensor, and that way, when we start with the Python code and we start adding hardware and getting ready to log data, we'll already have an entry in here that we can start with to play with, so you can kind of get a better understanding of it. So I guess we'll just call it outside. I'll do it in caps, and I'll tell you why. I find if I do it in caps, that if I keep everything in caps in the database, when we go to the Python code and we create variables in the Python code and I do everything in lowercase in there, then I don't get confused when I go to import that data from the Python code through this script in the Python code into the database, because you have to relate the value that Python has collected from the sensor itself with a database value. And it's really easy to get those mixed up. So I find that it's a good idea to pick either an upper or lower case for one or the other and stick with it. I just happen to choose uppercase for this. So this will be a decimal value, and it'll be 5, 2, with the parenthesis around it like that. It'll be not null. I better double check this. Yeah, uncheck not null, and it'll be unsigned 0 fill, and then we'll set the default value. So uncheck that, skip unsigned 0 fill, and the default value will be single quote 0.00. So here we're saying we'll go as far as 5 numbers wide. So we're saying 0.00 as a default value, but we could go as far as 000.00. That's 5 spaces wide, not including the decimal. And then we're saying with the comma 2, it says 5 comma 2, so 5 wide, and comma 2 says we're using a resolution of 1, 2, just so you understand what that relates to and what it means. Okay, so decimal 5 comma 2, we've set the default value there. So we've basically built our first table here for MySQL. And once you have it set up like that, we'll go ahead and hit apply changes. And it asks you if you want to create this table with these parameters, and you say execute. And it'll go ahead and create the table. And so now, if we close that table editing script and we go back here and we select the table and we ask for data from the table, even though we haven't collected any data, we see that the table comes back with our information. So that's a good sign. Now, let's see. Let's go back and make sure that that we have all of our settings right here. So we should have checked on the top ID 1, and timestamp should have 1 check. Checked on the top both, and timestamp should have 1 check, which means date time shouldn't. Is that correct? Yes. And then current timestamp and our time format. Yeah. Alright, good. So go ahead and hit apply changes again. Ask you if you want to modify the table by altering the table. Say execute. And we're done. So now we've created a table that we can start piping data into with our database and our Raspberry Pi. I suppose while we're in here real quick, I should point out that you can edit any of the data in any of this table, anywhere, anytime. So we'll just pick a field here. And if you click the field and you go down and click edit and then go back up and double click, you'll see that you can put a value in here. We'll say 58.52 degrees. And now you'll see that because we didn't collect data with the rest of this entry, that everything starts and shows up as null. So let's just go back and take a look at this again. And you'll see default value in here of null now. So you see how the database kind of like auto updates based on the parameters that you've set. Let's see, we could go in here and put a date. Let's just real quick close this and star from temps, order by ID, order by date underscore time, and then we'll say descending limit 100. Execute. Okay, so now we have a date time, so I don't have to type it all. We'll just highlight it, say edit, double click, Control C to copy, escape to fall out, and we'll go back to the other query browser and we'll put in a time. There you go. Okay, and anytime you modify anything, if you want those settings to stay, you have to hit apply changes, and you'll notice that the color changes here, and there you go. So now we've got time and date in. just to kind of help you understand that you can edit the table if you have to go back and later on and edit a specific piece of data, say because a sensor went bad or any other number of reasons you might need to actually edit the data. And so that'll help you understand how all that works. I think that is a good start for you for now. I recommend you go read up on MySQL query databases and tables, especially tables. I will put a link in here on how to create tables. The link is from the manual from MySQL, and so if you want to read more, you'll see that there's lots of other links there on the left-hand side on how to, so you can learn more about it. I think next time we're going to go ahead and finish up a couple of odds and ends on our install. Make sure that we have the appropriate libraries for the Adafruit sensor and for the Python code and those sort of things. And then we'll move on. We'll start working with Python code and adding hardware sensors and all sorts of exciting stuff like that. I hope you'll stay tuned and come back and watch more of these videos if they've been helpful. Love to hear your comments, constructive criticism, or that you just like it or appreciate it. Thanks for watching the Pharmacy Seeds Network.